Hello students, welcome to the new lecture session. Myself Shankhu Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandrasud Degree Engineering College under the JIS group. So now today continue this comparison between automobile and earth moving machine. So for here I will continue. Today we will covering another numerical on the power to on the basis of the power. So this topic is taken from the module number 1, and the topic and the subject and the top module number is name is earth moving equipments, and this topic is basically taken from the subject that is earth moving equipments and the farm machinery, and this is the 5th semester diploma students in automobile diploma in automobile students subject. So students, let's start the numerical on this class. As we can say here, an engine, here is the problem number 2. So an engine is required, and there is an engine is required to power a truck which is having a gross weight of 40937 Newton. Maximum grade which the truck which the truck will have the negotiate at 32 km/h in second gear is expected to be 15%, that is a percentage grade which is equal to the tan theta into 100. The rolling resistance coefficient is 0.017 and the air resistance coefficient is 0.0324 in the formula, where the total resistance equals to kfw plus ka into av square. The unit is kgf, where a is in meter square and v is in km/h, and the frontal area is 5.2 meter square. The transmission efficiency in second gear is estimated to be 80%. Now calculate the minimum power which should be available from the engine and the gear ratio in second gear if this power is available at 2400 rpm, and the coefficient radius of the wheel is 0.419 a meter. And beside this, also calculate the minimum speed of this vehicle in top gear on level road at the same engine speed, and assuming a transmission efficiency of 90% in the top gear. So what is the gear ratio in the top gear when the differential has a reduction of 3.92? So students, now coming to the solution part of this problem. Here, now note down the given data. Those are given in this problem. Here given the gross weight of the vehicle, that means W equals to 40937 Newton. Then here given speed in the second gear, this is V2 equals to 32 km/h. Then given the gradient, that is 15% equal to the tan theta 100. So there tan theta into 100 equals to 15%. So from here we got the theta equals to 10 inverse 15 by 100 equals to 10 by 100, 10 inverse, answer that is 8.53. Therefore theta value equals to 8.53. Name the given data is rolling resistance coefficient. Kr equals to 0.017. Air resistance coefficient is 0.0324. That means Ka equals to 0.0324. Frontal area is 5.2 meter. That means A equals to 5.2 meter square. Transmission efficiency in second gear is estimated to be 80%. That means transmission efficiency in second gear, that is 80% equal to 0.8. And there is also given speed of the engine, that is n equals to 2400 RPM. The effective radius of the wheel is 0.419 meter. That means radius of wheel equals to 0.419 meter. Transmission efficiency of 90% in the top gear. That means transmission efficiency in first gear equals to 90%, which is equal to 0.9, and the differential has a gear reduction. Gear reduction means differential gear reduction equals to 3.92. So these are the given data, and find out here. Number 1, minimum power. Find the minimum power. Number 2, find out the gear ratio in second gear. Gear ratio 2 means second gear. Gear ratio is the second gear. Then number 3, we have to calculate the minimum speed of the vehicle in the top gear, that's V1, minimum speed of this vehicle. And number 4, gear ratio in the top gear. Gear ratio, the top gear. So from this problem, from here in the problem, these are the given data and these are the finding. Find out the value of this. So let's start with this one, that is the find out the or calculate the minimum power is available. So for number 1, we know total resistance equals to rolling resistance plus air resistance plus gradient resistance, where rolling resistance equal to Kr, which is the rolling resistance coefficient, into W. W means the weight of the vehicle, where Kr is given and W both are the given. The Kr value of the Kr is 0.017 into W, which is given as value of W is 40937 equal to 40937 equals to 0.017 into 40937. Divided, we got 695 into 0.9, means 695.9 Newton. Now calculate the RA, air resistance. Air resistance equals to Ka into area for area frontal area of the vehicle, and then V square, as we calculate on the basis of the second gear. So here the velocity is on basis of the second gear. Now calculate this. Here the value of Kr, A and V2 are given. The Kr value is 0.0324, 0.0324 into A. Area is given, that is 5.2 meter square. This A equals to 5.2 into V is given, which is value of the V is 32 km/h. So the result, the multiplication, that is 0.0324 into 5.2 into 32 whole square, that is 172.5 172.5 Newton. And coming to the gradient resistance, the equation of gradient resistance is W sine theta, where W is 40937 into sine theta, means just calculate that 8.53. So this is equal to sine 8.53 equal to 0.15 into 40937, that is 6072.1 6072 means 6072.1 Newton. So now the value of R is equal to the summation of this 695.9 plus 172.5 plus 6072.1 equal to 695.6 695.6 plus 172.5 plus 6072.1 equal to 6940.5 6 and 6940.5 Newton, and we have to find out the minimum power. So from the equation of the transmission efficiency in second gear, which is equal to the R into V divided by P into 1000. So from this equation we get P equals to R into V divided by efficiency of transmission efficiency in second gear into 1000. Now put the value of this, where R means 6940.5. The transmission efficiency in second gear, that is 0.8, means 80%, means 0.8 into 1000 into V. Here V in unit of meter per second. So as we know, the velocity is 32 kilometer per hour. So 32 into 1000 divided by 3600. So from here we calculate this equation, 6940.5 into 32 into 1000 divided by 0.8 into 1000 into 3600. We get the value of power, that is 77.12 kilowatt. So the minimum power we got, that is 77.12 kilowatt. 77.12 kilowatt. This is the first answer. The second and so on. Second question was that to find out the find out the gear ratio in the second. This gear ratio in 2. Find out these things. We know the relation between the engine revolution or the engine speed versus vehicle speed. So the equation is that 2 into pi into radius of the wheel into n divided by g equals to 1000 into v divided by 60. Here G is the overall gear ratio. So from there we calculate the find out the G. G equals to 2 pi into radius of the wheel into n divided by into 60 divided by 1000 into V. Now put the value here, 2 pi into radius of the wheel, that is 0.419 0.419 into engine speed is given, that is 2400 rpm, 2400 rpm into 60 whereby 1000 into V. Here V is 32. So from this equation we get the value of G, that is 2 pi into 0.419 into 2400 into 60 divided by 1000 into 32, that is 11.85. 11.85. We know G means overall gear ratio equals to gear ratio in the second gear into the differential ratio. So from here find out the gear ratio in the second gear, that is capital G divided by differential ratio. Now put the value of here, that is gear ratio into equal to the value of G, that is 11.85 and differential reduction of dr, that is given, that is 3.92. So therefore the value of GR is 11.85 divided by 3.92, 3.02. So students, 3.02. So students, the gear ratio in the second gear, that is 3.02:1. This is the second answer. Now coming to the third questions, where we need to find out the velocity in the first gear or the top gear, which is have to calculate on the level ground. So in the level ground, the rolling total resistance equals to rolling resistance plus air resistance. The rolling resistance means KRW, where KR means 0.017 into W, the value of the W, that is 40937, which is equal to 0.017 into 40937, 695.9, 695.9 Newton, and the value of RA, that is KA into A into V1 square. Here K, the value of Ka is given, that is 0.0324 into A is given, that is 5.2 meter square, and V1 is not given, and we have to find out this. From here we got the RA equals to 0.0324 into 5.2, which is 0.17 into V1 square. So from here we get the value of R equals to 695.9 plus 0.17 into V1 square, the value of R. And here the given is efficiency of the transmission in the top gear, that is 90%. That means the value of the efficiency, that is 0.9, and this is equal to the RV by P into 1000. P into 1000. So from this equation, now I put here the value of here 0.9 equals to R is 695.9 plus 0.17 into V1 square the value of P, which is already calculated, that is 77.12 into 1000, as here velocity is put in this formula of the meter per second. So then, and we calculate here the V1, that is in kilometer per hour. So from here we get the V1 equals to into 1000 divided by 3600, multiply with this. So from here we get 695.9 V1 plus 0.17 V1 Q is equal to 0.9 into 77.12 into 3600, that is 249836. That is 249868.4. So from this equation we apply trial and error method. And we got the value of V1 equals to 101.8 kilometer per hour. So here we calculate this velocity at the top gear, velocity of the wheel at the top gear, that is 101.8 kilometer per hour. The last question, that is number 4, where we have need call the find out the gear ratio in the top gear. Gear ratio in top gear. As we know the relation in between the engine speed and the vehicle speed, that is 2 pi r n divided by g equals to 1000 v by 60. So from here we find out the value of g. G is the overall gear ratio, which is the multiply of the gear ratio in top gear into differential gear reduction. So now from here they got the from this equation, if I find that the g equals to 2 pi r w n divided into 60 divided by 1000 into v1. Now put the all value of here, 2 pi rw, value of rw, that is the radius of the wheel, that is 0.419. Now put here 0.419 into n is the engine speed, that is 2400 rps, into 2400 into 60 and divided by 1000 into v1, which we got, that is the value of 101.8 kilometer per hour. Now calculate this 2 pi into 0.419 into 2400 into 60 divided by 1000 into 101.8, and the gear ratio, overall gear ratio, value of the gear ratio is 3.72. and as we all know, the gear ratio equals to the multiplication of gearbox reduction ratio into in first gear, as we calculate find out that this top gear. So here this is showing 1 into differential reduction. So from here we got the gear ratio in the top gear, that is overall gear ratio divided by the differential ratio. G value is 3.72 and the reduction ratio, differential reduction value is 3.92. So from here we got the value, that is 3.72 divided by 3.92, that is 0.95. So gear ratio in the top gear, that is 0.95 is to 1. So these are the fourth answer. So students, here we solve another problem on this power calculate and the related to calculate the power, vehicle speed and the gear ratio. On the next class I will discuss on the continue the continue the comparison of the automobile and the heavy earth moving equipment. So still then, stay at home and stay safe. Thank you. Thank you, students. Thank you so much.